periodic table of elements, it's arranged in a very specific way, and there's a number of different periodic trends. The Russian scientist Dmitry Mendeleev was the first to put this together, and he's quite a genius for this because he predicted that each element has a specific place on the periodic table of elements. We will discuss all these periodic trends. You're looking at the chart. We have two columns here, and then here is our transition metals, and then we have 5 more columns, and then all the way on this side, that last column is the noble gases. And if you look above the chart, usually it will have Roman numerals. The noble gases will have Roman numeral 8. And hydrogen is over here. And this will have a Roman numeral of 1. This is oxygen and fluorine. The way it's organized is when you're considering what is in the valence of each element. The first column, hydrogen, only has 1 electron in the valence. The next column will have 2 electrons. We skip the transitional elements. These 5 rows, it goes 1, 2, 3, 4, 5, 6, 7, 8. This column, the noble gases, will have 8 electrons in their valence. The noble gases are the most unreactive species on the periodic table of elements. Why? Because they follow the octet rule. Their valence is filled with 8 electrons. They don't want to share. They don't want to donate. They don't want to accept. If we look at oxygen, he's in the 1, 2, 3, 4, 5, 6 row. So oxygen will have 6 in its valence. When examining oxygen, he's in the 1, 2, 3, 4, 5, 6 column. Therefore, he will have 6 electrons in its valence. Looking on the chart, he has an atomic number of 8 and a weight of 16. The first electron shell will only have 2. And then the next one will have 6. So oxygen will want to accept 2 electrons into its valence to fill the octet rule. Oxygen and fluorine happen to be very strong electronegative species. Electronegativity, represented with this Greek symbol with the negative sign, is the ability to attract electrons. Fluorine happens to be the most electronegative species on the chart, and then oxygen is followed right after that. And if you look at the valence for fluorine, it will have 7 electrons in its valence because it's in the 7th column. Considering a periodic trend, electronegativity of all the elements on the chart, which have a numeric value, it tends to increase in this direction, to the right and up. This is the periodic trend for electronegativity. Easy way to remember the strongest electronegative species is with this word Fonkel. Fonkel is a made-up word that describes that most electronegative species on the chart is fluorine, then the next would be oxygen, then nitrogen, and chlorine. And all these elements are right here on the chart. My arrow, if you notice, the tail of the arrow looks like a positive sign, pointing in this direction, indicating that fluorine is more strong than chlorine in electronegativity. That doesn't mean that chlorine is positive. It just means in relative. Another periodic trend that you'll see on the chart is the atomic radius. Atomic radii tend to increase in this direction, with the elements down here having the largest radius of electron cell.